In the last few examples, we had variable expressions, and we were substituting a number in place of the variable. In the next few examples, what we're going to do is not substitute anything in. The letters will remain letters, but we want to look at simplifying some algebraic expressions by identifying like terms. Like terms are terms that have the same variable component. That is, in example 16, we want to look at each term individually. Negative 4x is a term, plus 3y is a term, minus 12xy is a term, plus 15y is a term, and minus x is a term. Any expression separated by addition or subtraction is a term, and we want to identify which terms have the same variable component. In this case, we have two terms that have just an x. So negative 4x and minus x are like terms because their variable component is identical. Plus 3y and plus 15y are like terms because they both have a single y. The variable term is identical. And then minus 12xy doesn't have any like terms. There are no other terms that have an x times a y as that variable term. In example 17, we're again asked to identify the like terms. So starting with negative 2x, there are no other terms that have just an x. We have terms with xy and x squared, but those terms aren't identical. If we look at minus 4xy, there is another term that has x times y. So negative 4xy and minus xy are like terms. And plus 3x squared and plus x squared are like terms. But y squared is also left alone. There are no other terms that have exactly y squared as that variable component. So we can take this idea of like terms and use it to simplify variable expressions by first identifying like terms. In example 18, part A, we have minus 4b and minus 3b. The variable portion is exactly the same. And then we have plus 1 and minus 2. Those terms have no variable component, so those are referred to as constant terms, meaning they're just numbers. We can just add and subtract them together. So in order to combine these like terms, what we'll do is add the coefficients of those like terms. So for the terms with b, we'll have negative 4 minus 3 times b. And then for the constant terms, we'll have 1 minus 2. Simplifying, negative 4 minus 3 will give us negative 7 b, and then actually that'll end up being minus minus 1. So we identify the like terms and then add their coefficients together. Similarly, in part B, we have 8n, 4n, and 9n, and then we have minus 10 and plus 5, meaning to get our simplified expression, we'll add 8 plus 4 plus 9 times n plus negative 10 plus 5 as those two constant terms added together to give us 21n minus 5. In part C, now we have a slightly different problem because now what we have are some terms with an m and some terms with an m squared. Our m squared terms are like terms. We can combine those. Negative 2 plus 3 will leave us with will leave us with positive 1 m squared. Minus 4m and minus 9m are like terms, which will leave us with minus 13m. And then 1 and minus 10 are like terms, leaving us with minus 9. Or to just simplify this a little bit, we don't need to write 1 times m squared. We can just write that as m squared minus 13m minus 9.